Okay, so it's day 11 of Advent of Code, and we'll do some coding. And so far, we've had pretty good luck. Um, Hopefully, that will continue. And if it doesn't, then it doesn't. But as always, I'd like to get it done fast so I can go to sleep. Um, so welcome. And let's see what the problem is today. Maybe it'll be another Intocode computer. That could be enjoyable, or it could not be enjoyable. All right, 4, 3, 2, 1, go. Your plane lands with plenty of time to spare. The final leg of your journey is a ferry that goes directly to the tropical island where you can finally start your vacation. As you reach the waiting area to board the ferry, you realize you're so early no one else has even arrived yet. When modeling the process used to choose or abandon their seat in the waiting area, you're pretty sure you can predict the best place to sit. Quick map of the seat layout. The seat layout fits neatly in a grid. Each position is either a floor, an empty seat, or an occupied seat. For example, the initial seat layout might look like this. Now you just need to model the people who will be arriving shortly. Fortunately, people are entirely predictable and always follow a simple set of rules. All decisions are based on the number of occupied seats adjacent to a given seat. This sounds a lot like John Conway's Game of Life. If a seat is empty and there are no occupied seats adjacent to it, the seat becomes occupied. The seat is occupied and 4 or more seats adjacent to it are also occupied. The seat becomes empty. Otherwise, the seat state does not change. Floor dot never changes. Seats don't move and nobody sits on the floor. After one round of these rules, every seat in the example layout becomes occupied. After a second round, the seats with 4 or more become empty again. The process continues for 3 more rounds. At this point, something interesting happens. Chaos stabilizes, and further application of these rules cause no seats to change state. Once people stop moving around, you count 37 occupied seats. Simulate your seating area by applying the seating rules repeatedly until no seats change state. How many states end up occupied? Okay, so this sounds relatively straightforward. Again, it seems like John Conway's Game of Life variation. Raw equals this, and then I'll just say grid equals raw dot split on new lines. And what I want to do is I want to do I think this annotation should work. So I can say a grid is going to be a list of strings. Okay? No, that doesn't work because God, so much for from future import annotations. So if I'm typing import list, okay, so a grid is a list of strings. Okay, and so what I want to do is I want to say we're going to do one step which takes a grid, which is a grid, and returns another grid. And I want to return, let's say, stop that. This autocomplete is really irritating. So for I row in enumerate grid, and I don't know why it does that. For j, let's say c in enumerate row, and so next value grid I j for JCA. Okay, so that's good enough. So I just need a next value function now. So next value grid, which is a grid, I, which is an int, and j, which is an int, and that's going to return a string because these are strings. And what I want to say from collections import counter. Actually, no, I don't want to do that. What I want to do is I want to say neighbors equals and I'm just going to do -1, 0. And do we count diagonals, say? 8 diagonals, yeah. So I'm just going to look at the neighbors. -1, -1, -1, -1, +1. So those are the -1s. Then we have 0 and -1 and 0 and +1. And then we have 1 and 1. Notice that I'm using pluses sometimes. And 1 and 0. And then 1 and -1. So I listed these in like the stupidest possible order, which is good. So let me call those neighbors. Okay. So next value. But I do want from collections import counter. So let's say number of rows equals len grid, number of columns equals len of grid 0, and then count equals, so I want to count the neighbors, counter of grid I plus di j plus dj for di dj in neighbors if 0 is less than or equal to I plus di is less than number of rows, and 0 is less than or equal to j plus dj is less than the number of columns. Okay, so I want to count all the neighbors that are on but actually if a seat is empty and there are no occupied seats next to it, it becomes occupied. And so, and let's say C equals grid ij. I don't know if I want to do other. So if C equals L and there are no occupied seats next to it, the seat becomes occupied. So an occupied seat is a pound. And counts pound equals 0, then I want to return pound, so it becomes occupied. If a seat is occupied and 4 or more seats adjacent to it are also occupied, the seats become empty. If C is pound and counts pound is at least 4, then I want to return empty. And then otherwise, I just want to return what it is. Okay, so I have next value, and then I have step equals, let's say, list row for row in. I don't know what I just clicked on. So let us run this, and let's say grid, and then let's step the grid. And then step of the pound, and then step of the pound. So it's doing something. Let's go see if after one round of those rules, every seat becomes occupied. I didn't start with the right thing, but that's okay. I can check it. After one round, it was occupied because then I had that one. And then I got this LL, so that looks pretty good actually. But again, let me actually start with the correct layout rather than the wrong layout. Okay, and so now what I need to do is say after one round, every seat 3 more rounds. At this point, the chaos stabilizes. Once people stop moving around, you use 37 occupied seats. Simulate your seating area by applying seating rules repeatedly until no seats, how many seats occupied. Okay, and so let's say count eventually occupied let's say final seats, which takes a grid, which is a grid, and it returns an int. And so let's say while true, next grid equals step grid. If next grid equals grid, break, and otherwise grid equals next grid. So there's probably a more efficient way to do that. And I want to return some, how many seats end up occupied? So let's say C for row in grid for C in row if C equals pounds. Okay. What doesn't like about this? Expression of type int or string cannot be returned. How can that be int or string? That doesn't even make any sense. Some C for row and grid for C in row if C okay, no, it's actually right for rows. So it's not a matter of if. I just want to sum that up. Thank you. Pylance did me right. And so I want to assert that final seats of grid is, and what did it say, 37? 37. Yeah. Okay. So let us run it, and that worked. Okay, good. So let's get our puzzle input, which will probably be pretty big. Okay, with open grid equals, let's say, line dot strip. Let's say list of line dot strip for line in F, and then print final seats grid, and then probably in part 2 it's going to do something that is going to take too long. As F. So let's run that. So that already was kind of slow, 2152. So anyway, so probably in part 2 they're going to do something that's going to be like way too slow, and I'm going to have to be more clever. Continue to part 2. Soon as people have to arrive, people don't just care about adjacent seats, they care about the first seat they can see in each of those 8 directions. Now instead of considering just the 8 immediately adjacent seats, consider the first seat in each of those 8 directions. For example, the empty seat below would see 8 occupied seats. The leftmost empty seat below would see only 1 empty seat, but cannot see any of the occupied ones. The empty seat below would see no occupied seats. Also, people seem to be more tolerant than you expected. It now takes 5 or more visible occupied seats for an occupied seat to become empty. The other rules still apply. Empty seats that see no that become occupied seats matching no rule don't change for never changes. So this is going to take longer unless I think about this. So. All right. Well, I'll do it the brute force way, and if it's too slow, then I'll do something else. So I am going to need to make changes to actually. Let me make a next value 2. Yeah, let me just do def next value 2. I'll do this the naive way and we'll see what happens. Grid, which is a grid, I, which is an int, and j, which is an int, and that's going to return a string. And let me just copy this. Okay, that's fine. So now I'm going to need a helper, and it's going to be the first seat in each of those 8 directions. would see no occupied seats. So here's what I want to do. I want to say first seat, given a grid, which is a grid, I, which is an int, j, which is an int, and let's just do di, which is an int, and dj, which is an int, and that's going to return a string as well. So now what I'm going to do is follows, and again I'm going to can't type anymore. I'm going to do this, and I'm going to say while true, let's say I plus equals di, j plus equals dj. If 0 is less than or equal to I is less than nr, and 0 is less than or equal to j is less than nc. So I'm on the board. C equals grid ij. If C equals pound or C equals L, return C. Otherwise, I want to continue. And then else, I'm off the board. And so I'm just going to return the period, which says so once I go off the board, I'll return the period. Okay, so that's the first seat in that direction. So now for next value 2, what I want to do is I want to say equals counter first seat grid I j di dj for di dj and neighbors. And now they changed the rules as well. Now it takes 5 or more seats to be empty. Okay, so now this is at least 5. And so my only concern is that this is going to be too slow now. Let me, I hate doing this, but I'm just going to copy this all and do it again. So let me, part 2. I hate copying code, but I don't want to refactor it to not do it. So now I'll do step 2, which is going to use next value 2, and final seats 2, which is going to use step 2. Okay, and now assert final seats 2 of grid equals, and what did they tell me it's going to equal? 26. And I'm going to comment that out because it took a while to run. And so let's try this. See if I got it right. Okay, so I did get it right. So now let's see if this runs fast enough. And while that's going, we'll think about what to do if it doesn't. So if it doesn't, oh, well, 1937, so that ran pretty fast. That's the right answer. All right, cool. So that wasn't as bad as I thought it might be. This has a very like John Conway's Game of Life feel to it. And so John Conway's Game of Life, you have this rule of like a cell is live or dead, and then based on the number of neighbors, at the next step it's either live or dead. And so I did a couple things here. One is that I said, okay, given I probably, it would have been like much smarter to um, make these actually. So that's 0. Anyway, these are the 8 ways to get to neighbors from a given ij. You add, whatever. Okay, and, and so now I say, given a grid. So I worked kind of backwards, but now I'll work through forwards. So given a grid and a position I and j, I want to know. I don't want to modify it in place because I need everything in this grid to know like what every next step of the grid should be. So here's a function that tells me at position IA what is the next value going to be at this location. So I just count up the number of rows and number of columns in the grid just to make, because I don't want to go off the edge. I can't go off the edge. And so now I use counter. Counter's a good thing for counting. And I say for each neighbors, it gives me like a change in I and a change in j. And so I look at the grid, I plus 1, j plus 1, I plus 1, j plus 0, and so on. So the I plus di and j plus dj will be the 8 neighbors, but then this restricts to the ones that are actually on the grid itself. So if it goes off the edge, those will get thrown out by this if statement. So this allows me to count, empty seats, full seats, floor. And so that tells me like, well, what are all the neighbors doing? And then I say what is in this seat right now, and then we just apply the rules. If this is an empty seat and we counted no occupied seats in the neighbors, then the seat gets occupied. If this was an occupied seat and we counted at least 4 occupied seats in the neighbors, then the seat becomes empty, and then otherwise we just it stays as is. We just return whatever it was. So that sort of our smallest piece. We take a grid and we say what's the next value at I and j. And so now we do like an immutable data structures thing. So like I said, I don't want to modify my grid in place because I need to know every state of this grid to figure out like what's the next value going to be at each point. And so if I start changing it as I go, then I'm going to have those changed values and get the wrong answer. And so that's why I define this step function that takes a grid and returns an entirely new grid so that all my computations are done on the old grid. And then I just use a couple nested list comprehensions and this next value function. So, and it turns out I didn't need this C. That's fine. I'll leave it there anyway. And then the final seats basically just said, so like, one thing you could do, and this is what I maybe should have done, let's say import itertools, because itertools is better, and that would save me from having to do this. And I think it's itertools dot accumulate. Is that right? No. Anyway, maybe I don't want to do that because I would have to whatever. I'll just stick with the while loop. I don't need itertools. That would have been like a slick solution, but what I did worked. So I just do a while true, and I just apply step to the grid. So I say, what will the next state of the grid be? And like I said, if we reach a stopping point where it's the same as before, I'll just break out of the loop, and I actually could have just put this return statement there instead of breaking out of the loop, but that's fine. I'll leave it. And then otherwise, I replace grid with next grid, and I just keep going and keep going. So that's fine. So that worked. In part 2, they changed the rules and did this kind of line of sight thing, right? And so now instead of looking at the neighbors, I need to go as far as I can in that direction until I hit a neighbor. So the main thing to do was this first seat function, where now I say I have a grid, I'm at position I and j, and I want to look in the direction determined by di and dj, and what is the first seat that I see? Is it occupied? Is it empty? Or I'll just return a dot if there's no seat in that direction at all. So again, I need to count rows and columns so they stay on the board. And again, I do a while loop, which I'm not thrilled with, but I don't like doing while true loops like this. I would rather do itertools, but this worked, so I did it. So while true, repeat forever, move I and j in the direction, and then check that we're still on the board. And if we're not still on the board, we didn't see a C, so return period. Otherwise, we are on the board. So, see what's at that position, and if it's a full seat or an empty seat, return that because that's the seat that we see. Otherwise, you know, repeat the while loop and keep going. So that does the go off in one direction. And then I just modified next value and step and final seats to use that function instead of the neighbors themselves. So instead of just counting the neighbors, I do the first seat in each direction for, and so maybe I shouldn't have called these neighbors, but whatever. And it worked. So that was good. I'm happy. Thanks for watching. Have a good night. I'll see you tomorrow. And yes, I'm going to stop.